Welcome, everyone. It is Dr. Dickinson, and we are live on Hacking Teacher Prep with Dr. D. Today, we are joined with a good friend of mine, Ann Elise Record, who is a math consultant out in New Hampshire, and she is here to share her expertise on building math fluency with math running records. Ann Elise, welcome to the show.
Thanks so much for having me. I'm happy to be here.
Absolutely. It's great to have you. Thank you for your time. Can you share with our audience a little bit about yourself? Tell us, what you've been doing and how you got started in becoming a math consultant.
Sure. My undergraduate degree is in sociology, and I went back to school to get my master's in order to teach, and got my master's in education, certified to teach K-8. But the only math class that I had to take, because I had taken some math classes in undergrad, was math and literature. So I really did not know how kids learn math, even though I was certified K-8. I think the assumption was I would be given a textbook to follow and just do it lesson by lesson. So I taught grade 5 for 13 years, and then I became math coach K5. And that was really the time where I realized, I have to learn, how do you teach a kid about the number 5? I did not know. I was just used to my 5th grade curriculum. And that was really my in-depth journey of beginning to learn about elementary mathematics and early numeracy and the complexities involved in children learning math. And then I did the coaching job for 4 years, and my husband got a new job 2 hours south in New Hampshire. And I was like, what am I going to do now? But I had befriended Dr. Nikki Newton as well as Christina Tondevold, and the two of them are nationally renowned math consultants. And so I had become friendly with them, and they both encouraged me to go off on my own. And so I have, and it's just been a dream. This is my 3rd year doing it, my 4th school year now doing it. And it's just been phenomenal to kind of spread the positive math vibes to everyone and to have everyone understand that everyone can learn math.
Absolutely. And we actually met in the Facebook group. And so social media is just blowing up as a platform for teacher professional development. So for those of us that are out there listening, wondering how they can get involved, what is math running records, what is building math minds, tell our viewers out there what they can do to get started.
Absolutely. And that really was a lifesaver for me. I was living in northern New Hampshire at the time, and there weren't many of us living up in northern New Hampshire. And so I found the most amazing professional learning community online. So in Twitter, there's a group called Elementary Math Chat every Thursday night at 9:00 Eastern Time. It's called #LM, so ELEM Math Chat. And that was my first introduction to chatting once a week with other like-minded people, and the resources that are shared. It's an amazing community of people that they're just generous and kind and amazing. So I really enjoy doing that. Still do. And then in Facebook, I created a math profile, and I only do math posts. So there's a growth mindset logo for me. And I just follow math people on Twitter and on Facebook. And the groups in Facebook, it's my home, I consider it, because I'm able to share so much, videos and resources and advice all the time. Is a lot of what I do. So I facilitate both the Math Running Records Facebook group as well as the Build Math Minds Facebook group. So Build Math Minds is the site for Christina Tondevold. She began that site many years ago now. And so I facilitate that group. There are 65,000 people in there. So if you have any questions about teaching math, or if you just want to read through and learn, it's an amazing wealth of knowledge. And then the Math Running Records, I facilitate with Dr. Nikki on the Math Running Records, obviously, the interview protocol of talking to kids about their thinking with basic facts. But it's really about creating a foundation of flexible thought that will follow the students through their entire math journey. So really powerful.
I actually have a colleague of mine who teaches at the university with me, and she got the training from Dr. Nikki Newton about how to facilitate a math running record. Mm-hmm. So in week 2 of the course, they get to watch a video of one of our faculty at National University doing a running record assessment with my daughter.
Oh, fun.
Yes, I'm going to give you permission to put it in the course. And then the students get to analyze the video and think about what best practices they would then use to support her based on how she responds to the questions and how she's performing on the running record.
That's fantastic. I love it.
I mean, I love it too, because, initially when I started teaching first grade, I mean, about Fluency running records, but there was nothing for math. And
right,
so
exactly.
It's great to see that evolution, because yes, we need to lay that foundation. So you're here tonight to talk about the fact fluency, the foundation. So I'm going to let you go ahead and share our presentation. But if you're out there watching, thanks for joining us live on Hacking Teacher Prep with Dr. D. Please feel free to use the chat, ask Ann Elise a question, and let's just take it all in and soak in that knowledge. Get your paper and pen ready. Let's do this.
Awesome. Great. Thanks. Yeah, let's get going. So, first of all, I do want to share with you the various ways you can be reaching out online, because I have found the online group of people in my favorite professional learning community, and I am immersed in it every day. So I'm happy to talk math with anyone at any time. You can certainly reach out. But I do have my own webpage. It's anneliserecord.com. I do have some Padlets of resources that are free on there for you. I also have some mini workshops that I've created on different topics that you could check out there as well. But then there are the Facebook groups as well. So Elementary Math with Ann Elise is my own consulting one. But then there's Math Running Records, which has 15,000 people, and Build Math Minds with 65,000 people, where it's just a big community of people that are willing to share resources and ideas and just support each other on this journey of helping children have positive math journeys. On Twitter, you can follow me as well, and on Instagram. And the bottom of the screen, you can see what's called a Padlet. Now, that's a web page that has resources on it that is not affiliated with social media or anything. It's just a web page. You just need that link, and it's a tinyurl.com/mathrr. And there are tons of resources I put on there for you for basic fact fluency and math running records. So I just wanted to share all those resources for you. It's going to be a rabbit hole of time on that Padlet, but I just want to be able to provide at no cost, information for people to help us all understand the trajectory of learning of our elementary age kiddos, and then help them on that math journey to make it a positive math journey for all the kids. So I am on this journey, and I am still on this journey. I have been immersed in the elementary math world 10 years now. I've been an educator for 20, but really immersing in the deep understanding of elementary math. And I'm still on this journey. I still learn new things every day. So those, all of you out there that are pre-service teachers, welcome to the profession. I'm so thrilled to have you here. One of the things I have done in my life is also teach mathematics classes as well. And I was really actually surprised to find out how many of my students didn't like math. And it was going to be a part of their career, right? Because as elementary math teachers, we have self-contained classrooms. We do all subjects. And so many of them, I was shocked, actually, how much they didn't like math. And this is actually turned out to be true for a lot of people that I meet, the teachers that I meet, the parents that I meet, that it's just this negative journey of math. And so I actually, in my mathematics class, did have my students purchase the Math Running Records book. I trained them on how to give the assessments, and we had students come into our classroom, and my students interviewed the young kids, and then based on what they found in the running record, they gave them games and activities to take home with them. But my pre-service students felt like they were so prepared going into the student teaching because they had already a sense of what to look for with the kiddos and with their thinking. So, but yeah, so I'm still on this journey. Welcome to this journey. We're all at different places on here, but just know that the journey will continue forever. But it's a wonderful journey to be on. So in our session tonight, I do want to share a few things with you about fluency. So defining what fluency is, I want to share with you the Math Running Record because it's a lot of my consulting work. I find that it is a phenomenal way. It incorporates everything that I know to be true with best practices with elementary math, and as well as getting the most authentic data we can get on our students' thinking, right? And then I also want to provide you some resources. The Padlet will be there for you as well. I'll show you a few games tonight you can play with kiddos that can be differentiated to the needs of the kids. But I really do want to build your math mind. So Christina Tondevold runs the site buildmathminds.com. She's got a podcast. She's got tons of free resources and videos that she's done as well. But it really is about us building our math minds so that we can then facilitate building the math minds of our kids. And so I do, as part of tonight's work, I want you to understand the trajectories of learning of the kids that I know I didn't get in my training to be a teacher. So the fact that you can be learning this as a pre-service teacher and then be embarking on your career and all the lives you will touch in your career, it's a pretty powerful thing. So I do want to share at first just the first feelings of the trainings that I do, and I ask people to put in some words that they think about their own childhood journey of math. And now the word fun is rather large in there, larger than I would have thought, but then it occurred to me, words need to be exactly the same for the words to get bigger. So if you see frustrating and frustration, they're big, but they're not the same exact word. So fun would not be as large if we were able to kind of categorize these with the same meaning. Because unfortunately, I would say about 80% of people that I meet are very negative about math journeys in their lives, and several are really phobic about the math. And I want to make sure that we all understand we all can learn and grow when they learn things in ways that we know through research that the brains work best. And, in our society, math gets bashed a lot. It seems acceptable, on a lot of television shows. I'm more aware of it now. Math really does get bashed, right? The idea that math teachers don't celebrate Halloween. We are Halloween. Like, can you imagine that for reading, right? And these are t-shirts that come across my feed at Halloween time where teachers will comment how much they want to get that and wear it. And I want to make sure that we are aware of what messages we're sending our students, the fact that everyone can learn math. And when I ask them, people, why these negative things have happened, I cannot tell you the amount of people that have said time tests. That was the start of the math anxiety. I'm adamantly opposed to giving time tests. That definition of fluency being speed and accuracy, we need to widen that definition and not, the research has so overwhelmingly shown that it's the start of math anxiety for our kids. So I was in the room when Marilyn Burns said, and she's a math guru of math gurus, and she said, time tests had a birth, they can have a death. I just loved it. And I want to just share with you just positive messages we can have with our kids about math. On the left, Math Gals, you'll see those are women mathematicians. There was a Christy Newell and her daughter Cora created a whole series, a webpage of Math Gals, because they didn't know many women involved in mathematics. And so it's a whole movement of Math Gals, as well as on the right, Berkeley Everett's one of You Are a Math Person. So, we want to be positive messages. And the growth mindset messages out of Stanford, Joe Bowler's work and Carol Dweck's research on every child can learn. We all can learn and grow. And our brains are plastic. Our brains can learn and grow. It will make new connections in our brain that we build from what we know to what we're learning. And so I liken it to be like a beach path. You go down the path once, the grass would regrow. But if you go down it over and over again, it becomes a permanent pathway. That's what's happening in our kids' brains. We're building these new neural pathways, making connections with mathematical concepts as they grow older. And I'm going to share with you how some of the same strategies we do with basic facts can be extended to those larger numbers and even decimals and fractions, that whole entire journey. And I love this quote from Joe Bowler. Certainly, as you guys are embarking on this journey of becoming teachers, the idea that we too long have labeled students. We say high, we say low, we say struggling, and we've got to make sure we're being very careful and not labeling our students that there's nothing saying that they can't learn. The potential for learning is there. Their current achievement is a result of these experiences building those pathways. We need to create those pathways and help them facilitate that. I do want to share with you also this really impactful graphic by Pam Harris of the development of mathematical reasoning. This is the K12 Math Journey of our kiddos. So in the beginning years, the kindergarten year, that counting strategies, that counting and cardinality is essentially the first kindergarten full year of schooling. As students are in grade 1 and 2, we do want to help move them, facilitate their movement into additive reasoning. We'll go into depth about that tonight, about adding and subtracting. But there also is a whole world of multiplication and division and multiplicative reasoning. And very often our kids get caught in a previous phase of reasoning. So for example, if I ask students 6 plus 7, many kids will count on the 6 from the 7. But that's a counting phase of reasoning, right? That's not additive reasoning, like, I could use the fact that 6 and 6 is a 12 to help me. And similarly in multiplication, if they're doing a multiplication problem, students very often skip count because they haven't, learned and mastered what the facts are. So they skip count, but skip counting is an additive reasoning. It's not multiplicative reasoning. Just being aware of this journey, the grades 6 to 8 is proportional reasoning phase. And then finally in high school, that functional reasoning. So we'll focus tonight on these first two, the counting strategies and the additive thinking. But do know there are resources for you there on the Padlet with multiplication and division as well. I'm happy to answer any questions you have about that. So if I were to ask you what words come to mind when you think of fluency, you will probably think of your own journey of learning math, unless perhaps you've had a course already with Dr. Dickinson and learned that fluency is more than speed and accuracy. NCTM updated the definition of fluency here, and I love this definition. It includes the words flexible, so flexibly, and efficiency. So the definition of fluency is not just speed and accuracy. One may define it that way, which many of our parents will define it that way, because that's how it was understood when they were kids. But the idea that fluency is more than being fast and accurate, is that flexible and the efficiency, and really crucially, the making the choice of which strategy is best for the numbers that we're given. It's not just becoming a calculator, so when you see numbers, you just want to crank out an answer, but it's taking a beat, looking at those numbers, whether they're single-digit math facts or whether they're larger multi-digit operations and numbers or fractions and decimals. Like take a beat, look at the numbers, say, what do I know that can help me figure that out efficiently and flexibly, and not just cranking out in a traditional algorithm. So with that in mind, then these four aspects of fluency, that flexibility, the efficiency, so choosing a strategy that works best for the numbers that we're given, accuracy, of course, we want them to be accurate, and that instant recall, that relative speed with it. Of course, we don't want a student prolonged thinking with the basic facts, but we do want to honor the fact that may be some students that may take a little longer, and that's perfectly fine, right? That does not mean they're not a good mathematician. We need to redefine what it means to be a good mathematician, and speed is not an element of that. When I think about the basic fact fluency traditionally of kids, they will start the journey right there counting, and they'll use their fingers to help them count, which is totally fine. And then when we ask them a question about a math fact, they will look off into space. And they'll wait for that number to kind of come in their mind of what the answer is. They're not doing any mathematical reasoning. They're just waiting for this number, as Logan research shows, of popping into their mind. And then how do we assess them to see how they're doing with their fact fluency? Well, we've traditionally given them time tests. We've defined fluency narrowly as speed and accuracy. Now, another journey that I want to share with you tonight that includes the math running record is a very different journey. It's doing activities in the classroom, daily routines and activities of number talks, and showing math tools and asking the kids, how many are there and how do you know? Now, there will be some students that might count them one by one. So you'll know that. You'll be, they're in a counting all phase of reasoning. Other students will count on. They might start with the 6 beads and then count on the 7. But other students will know I can begin counting on from the larger number. It's going to be easier for my brain. I'll start with that 7, even though it comes second, and I'll count on the 6. Now, those are all counting phases of reasoning. So even if a student is in grade 1 or 2, if they're counting on, it's a counting phase of reasoning, which unfortunately also happens with double-digit work when students are doing the algorithms too soon. Right? The algorithms are single-digit basic facts, and they end up counting on with those facts. Whoa, we need to have them additively thinking of their reasoning, right? Well, here's what it sounds like when there's an additive reasoner. They can say, well, I know already that the 5 red beads in each row is 10. So already, without having to count, I know that's 10. And then within that 6, there's 1 more. Within the 7, there's 2 more. So that's 3. So I can rename 6 plus 7 as being 10 plus 3. Much easier for my brain. But yet another student might say, well, I know 6 and 6 is 12. And so I can use that to help me solve 6 plus 7. It must be 1 more than 6 plus 6. So it must be a 13. Other students have used the doubles of 7 and then they remove 1, right? It's not dictating what strategy students use. It's using a strategy that makes sense with the numbers that are given and that makes sense for your brain. That's efficient. And another student might say, well, I can decompose. I can break apart that 6 into 3 and 3 and give 3 of that 6 to the 7 to make a 10. If I know 7 and 3 make a 10, I can take that 3 from the other addend and then rename it again as 10 plus 3, which is much easier for my brain. That's the flexibility, being able to see a variety of strategies that are using number relationships to figure out the answers when we don't know an answer. So we're not falling back on counting strategies. We're thinking, well, what facts do I know that can efficiently help me get there? And how do we have our students practice? Well, we have them play games and activities and talk about their thinking and their reasoning and their strategies. And how do we find out how they're doing on that journey? We talk to them. We ask them questions with basic facts and see what are their phases of reasoning, and on that trajectory of learning, find out where we can begin working with them to provide that instructional response. So this is all the work of Dr. Nikki Newton. She spent 10 years poring over the research and doing her own action research with hundreds of kids around the country on math learning records. So she was a literacy person first. So her first few books are Guided Math, based on the guided reading, math workshop, as well as math learning records. So that literacy framework of the guided reading, why won't we do the same thing for math? Very often people have not thought about doing it for math. So I do hear a lot in my consulting work that I've heard of reading running records, but math running records, and it's a parallel journey, early literacy and early numeracy. And so in the book is all the research and all the research that's based on this work. Every marking on the recording sheets has been researched based. They are a free protocol. They are on her site called mathrunning-records.com. So you go onto that site, you can just scroll down middle or so, and you'll see the 4. There's 1 for each operation. You can just download it for free. And then, a lot of resources here to support you on that journey as well. So I do facilitate this Math Running Record Facebook group. So even if you don't care for Facebook, you can join for just a math profile and just join the group. But it's really the only place that I know of right now that can give as much of this feedback and give advice and sharing of things. Lots of resources for you. We just did a book discussion, she and I. So there are 3-hour-long videos of she and I talking about Math Running Records with all 4 operations that are right in the group available for you as well. So let's talk for a second about the Math Running Records. So it's going to give us a reading on all 4 aspects of fluency in this one about 10-minute interview with kids. Now, part 1, the students will have a sheet in front of them that is going to benchmark expression for each of the strategies in the progression. And again, there's 1 of these for each operation. So through the research, Dr. Nikki's created from the easiest ones of like adding 0 to the hardest ones when you have teen sums, this trajectory of the strategies. Part 1 takes about a minute. We're asking them to get a relative sense of their relative speed and accuracy. We ask them to give the answers to these benchmark 1 expression in each strategy zone. But part 2 is the heart of the running record. It is the time we go deep. We ask the students exactly, what did you just do? What number did you start on? Can you show me that with your fingers again? Like asking them everything so we know what they're doing to solve. And then finally, the math disposition. How do they feel about themselves? What's their math identity? Do they like math? Do they know they can figure things out and persevere? So it's about 9-10 minute interview with a student. And very often I find teachers asking about the time, right? How do I find the time for that? When I ask them, well, what do you do for literacy? They give a lot of time to measure the literacy. We got to do the same thing for the math. So I want to share with you the Math Running Record for addition first and talk about the heart of the operation. We want to make sure we know what we're listening for when we are interviewing the students, right? So here is the page that would be in front of the students. So that 1 piece of paper is in front of them. It is a mental math assessment, so you don't have manipulatives out on the table. Although if a student does ask for them because they're stuck, you can give it to them, but then go on to the next part of the running record. You learned what you need to learn. But there's, again, 1 expression in each of the strategy zones. So we have adding 0 to numbers, adding 1, and then adding within 5. So the hope is, not every student achieves this, but the hope is that by the end of kindergarten, students are fluent within 5. They know how to add on a 0, add a 1, and then the facts that are sums within 5. So that's the hope, that by the end of K, so this is appropriate for the end of kindergarten to talk to the kids with this. By the end of grade 1, we would hope they be fluent, all 4 aspects, by the end of 1st grade. And then 2nd grade would be the completing these. So the hope is that grade 3, 4, 5 students have all their facts for adding and subtracting within 20 all set by the time they enter grade 3. Now that is not the case. I see a lot of 5th graders counting back within the algorithms of subtraction in a division problem, right? So it just becomes like a snowball effect when we haven't set that foundation for our students. But the progression of the strategies going within 10, that they're going to be counting on within the 10, but we also want to work on decomposing and breaking them apart to all their pairs of addends so that they know that a 2 and a 6 make an 8 without having to count on the 2, right? And then the top parts on the right-hand side, that the top 3 are related doubles, because very often our kids tend to know the doubles facts, so we can build on that. But also in the bottom 3 are the decomposing to make a 10. And that's the most powerful strategy because it can get forwarded to the nearest 10, the nearest 100, and the nearest whole in our multi-digit work and decimals and fractions. So we want students to be aware of that with the strategies as well. Now, honestly, my consulting phrase is that there's nothing elementary about elementary math. And I did not know any of this when I emerged with my teaching degree. So I really want pre-service students to learn all about this. So you're embarking on your career, having this knowledge about how kids learn mathematics. So the research has shown that kids go through a developmental progression, beginning with counting all. So if I were to ask them 3 plus 2, they put out 3 fingers and 2 fingers, and they count them all starting at 1. Now that progresses to counting on. They know they can have a starting with one of the groups and count on the amount of the other group. And within that, we also want them to understand to count on from the larger addend. That'll be easier for their brain, which is why 2 plus 6 is asked in the way that it is, to see do they count, if they're counting on, do they begin with a 6 at least, right? So those are all the counting phases of reasoning. And then also level 2, because these are the codes on the recording sheet, that you can be counting on mentally, which is thought to be a hierarchy of the next level of counting on mentally. Now, 3 is the heart of these derived strategies, using doubles to help you, breaking apart to make a 10, all those derived strategies. And that's kind of the group that's been missed the most. Kids are usually going from the counting on to, okay, now memorize them, right? But no, we've got to do that derived strategy phase. It's such an important, that's the key to building number sense and the key to building their fluency. And finally, the level 4 would be they've arrived at the mastery. They do know the answers, and they're relatively fast, and not that the speed is the end all and be all, because it's not. But we also want them to have the understanding that they didn't just memorize the answers. So when students give me an answer and I ask them, how do you know? And they say, well, I just know it. I'm like, well, that's wonderful. But what about a friend who doesn't know it? Could you help them? What advice would you give them to solve it? And see if they tell them, because the kids will tell me. I tell them to get some flashcards and memorize them. So that's how I know how they learned them, as opposed to telling the kids, well, they could start counting on from the larger number, or they could think about a fact that they know, like a doubles fact, like those kinds of reasoning strategies is important as we listen to the kids. So we're aware not only here of what sets of numbers do we want the students to begin working on, but within that set of numbers, where are they on this trajectory? We're not going to be able to take them from counting all to automaticity in one step. We got to be able to help facilitate their journey forward in each of these different strategy levels. So I wanted to show you what a math running record looks and sounds like. This is me. I had reached out to my Facebook group and asked if there are any children I could talk to over the pandemic when it first happened, because my consulting work came to a screeching halt. And this is a young girl living in South Africa. I interviewed she and her sister. So here's a math running record. This is the addition one. And you'll see part 1, I'm going to go through the answers to some of these. We're not going to do all of them. Then in part 2, I begin again, and I begin asking her about some +0 facts and having her articulate what's happening when you add 0 to numbers. And then when I decide I found a good zone for her to be, I move on to that, do you enjoy math? That disposition, the part 3. So you'll notice that's when that one kicks in. So here is a math running record.
So I'm Mrs. Record, and I'd love to talk to you today about your thinking around addition. So on the screen, you can see some problems there. Now, we might not do all of those, okay? We're going to do some of them. I'm going to ask you what the answers are, and you can feel free to solve it in any way that you want to. If you want to use your fingers, if you want to count out loud, but I do want to be able to see what you're doing. So if you want to use your fingers, just put it up in front of the camera so I can see what you're doing, okay? And then in part 2, I'll ask you some more questions and how your brain is figuring them out and what you were doing to solve them, okay? And while you're sharing your thinking, I'll be taking notes so I can look back afterwards to figure out how I can help you get even better at math, okay? All right, so let's start there at the top. What is 0 plus 1?
0 plus 1 is 1.
And 2 plus 1?
2 plus 1 is 3.
And 3 plus 2?
3 plus 2. 7.
7, okay. How about the 2 plus 6?
2 plus 6 equals 8.
And 4 plus 6, the one beneath that?
4 plus 6 10.
And 10 plus 4?
10 plus 4 is 14.
And how about the top of the next column? 7 plus 7.
7 plus 7 is 14.
And the one beneath that, 5 plus 6?
6, 7, 8, 9, 10. Wait. It's 11.
Okay, super. Now I'm going to go on to ask you some other questions and have you explain to me exactly how you're doing it, okay? So let's see, how about 3 plus 0?
So 3 plus 0, when I'm doing 3 plus 0, I know I know it's 3 and then you're just adding on 0, so you're adding on nothing. So then it's 3.
Gotcha, okay. How about 10 plus 1?
10 plus 1 I know is 11 because I know like 10 plus 4, 10 plus 3.
Okay.
I know all those.
How about if I asked you 8 plus 1?
8 plus 1 is 9
So how do you know that?
because we're just adding on 1.
Okay. How about 2 plus 2?
2 plus 2, I know my double, so I know 2 plus 2 is 4.
Okay. How about 1 plus 4?
1 plus 4 is the same. I know it's 1 plus 4 is 1 plus 4 is 5 because you're just adding on 1.
And how about 2 plus 3?
2 plus 3 is, for 2 plus 3 I'd have to use my fingers.
Okay, go right ahead. Show me how you do it. So 2 plus 3.
3, 4, 5. So that's 5.
So I just asked you 2 plus 3, and I noticed you started with the 3.
Yeah.
I'm curious why you started with the 3.
I always start with a bigger number because I don't have to count on longer.
Gotcha. Okay. How about 2 plus 7?
2 plus 7, I just have to use my fingers. So
Sure.
7, 8, 9. So it's 9.
Okay. I'm going to give you a number, and I'd like to know what number you need to add to make 10 with it. So if I give you 5, how many more make 10?
5.
What if I gave you 9?
1.
How about if I gave you 2?
8.
And 6?
6, 7, 8, 9, 4.
Okay. And a 3. What if I gave you a 3?
A 3, we would need a 7.
Okay. Do you like math? Yeah. Now, looking at that sheet of problems there, do any of those look really easy to you?
The 0 plus 1 is pretty easy.
Okay.
2 plus 1 is pretty easy. 10 plus 4 is easy. 7 plus 7 is easy. And yeah, that's all.
Okay. How about anything look tricky to you?
3 plus 2 is pretty tricky. 2 plus 6 is tricky. 4 plus 6. 5 plus 6. 7 plus 5. 9 plus 6. 8 plus 4. And 7 plus 8.
Super. Now, when you're working on math and you get stuck, what do you usually do?
I normally use a easy strategy, but if I get a bit stuck, then I would normally use my fingers. But if it's a really high number, then I would see if I can use my doubles.
Ah, great. Super. Well, thank you so much. I really appreciate your time today. Have a great day.
Okay, bye.
So sweet. So I want to show you what the recording sheet looks like for the running record. Now, don't get nervous. I know it has a lot of codes on it, but once you get familiar with it, of course, it's fine. But it's all research based of all the different codes that are on here that Dr. Nikki did for us. So you notice here in part 1, there's a little spiel to read to the kids. We want them to understand we may not do all the problems and that we're going to take notes of what their thinking is. But you can see here that the accuracy, I put a check mark if it's right, or I put an X if it's wrong with a number that they said, so I can error analyze later. So her accuracy here, she had one wrong, but these were all correct. And you can see this relative speed. A is for automatic. These codes are right down here. That's within 3 seconds. 5S is 5 seconds, and then PTH is prolonged thinking. So I can see it was kind of quick here, prolonged thinking, went back to being fast, prolonged thinking. Right? So generally you can kind of see where things begin taking a slowdown. These are the codes in terms of the counting all, finger counting on, head counting on. Again, these codes are right down here. And you circle these if they're obvious in part 1. And then that also associates itself with one of the levels from 0 to 4. And again, those levels are right here where you have 0, that they have no idea how to attack it. The counting strategies with physical objects and fingers. 2 is the mental counting strategies. 3 is those derived facts, and then the 4 is that mastery. But 4M is they've memorized it only. They don't have any background information to support it. It's just memorizing the answers only. Then in part 2, there's a box for each of the strategies with extra expressions that Dr. Nikki has chosen for us on purpose and in purposeful ways to be able to ask them. And now, I chose not to ask her all of these. She was pretty quick with this one, and she explained it well. I also, with the +1, chose to give her just a couple. And we're trying to decide on these progression of strategies, whether the students have those sets of number facts down, or should they be working on them? Do they have any that are taking super slow or inaccuracies or inefficient strategies like the counting on? So the +0 and +1, she was fine. But this within 5, this one fact of 2 + 3, for some reason, it looks tricky to her, even though 7 + 7, 14. And that she knew almost all the pairs that made a 10, right? She's memorized those. But the 2 + 3, for some reason, still looks tricky to her. She finger counted on. So this is the zone I'd want her working in. So I have the word emerging that I circled here, that these are the facts I wanted to focus on. I did happen to do one strategy more to see how she did it, because I find her to be fascinating, that the 3 + 2, she's going to bring her fingers for, but yet so many other ones that look harder that I thought were harder, which is what the beauty of math running records. When you talk to the kids, you are always surprised with what they come out with and what they do. But what I did is I stopped it here because I found a couple that are emerging where I'd want her to work. So I stop the interview, go on to part 3. I ask her for the disposition questions. And then I decide on my instructional response. So I would want her working on adding within 5 in terms of decomposing numbers. I want her to learn the combinations that make a 5 without having to count, to know that a 5 can be a 4 and a 1 and a 2 and a 3 and a 3 and a 2 and a 1 and a 4. Like those partners of add-ends I want her to know by doing lots of decomposing activities. Then I'll have her go on to the number 6, breaking it apart to the pairs of add-ends all the way up to 10, so that she knows those, so that when I ask her facts within 10, she'll know the sums because she won't have to do the counting. So this is like what strategy, what numbers do I begin working on with her? And then within that strategy zone, what is her current behavior? So right now she's at a 1 being finger counting on. So it tells me as a classroom teacher or an interventionist, okay, I want to work with these facts, and I know she's right now finger counting on. I want to help her maybe count on, you notice she put out all the fingers, right? So she ran out of fingers when it went over the 10. So maybe she could work on putting one number in her head and counting on the other one. Or can I get her to just count on, put the number in her head and count on in her head? As we work on these more sophisticated strategies and using the doubles. So that's, the math running record looks very similar, all 4 of the operations. So once you get used to the format of it, there are very different thinking that's going behind the different operations. But for addition, that is what the running record looks like. And there's one sheet. So I use that interview for kindergartners that I meet, as well as middle school students that I interview. So the cycle of engagement here, the cycle that we go through is we're talking to the students about their thinking. We are observing what they are doing. We're watching them. Are they counting on in their head? Are they using their fingers? We then analyze the recording of that interview to figure out, okay, where do I want them to begin working? Dr. Nikki calls it the GPS of fact fluency, that you find out exactly where they need to begin working. And then finally, we do a plan. Like, what is my instructional plan for that based on that information? So for things like what I saw with her, where she was counting on, it was great. She was counting on from the larger number. So that was awesome. But I want to help her move past the counting phase of reasoning. So I would be doing whole group number talks and number strings, which is different expressions that have the same strategy that can be applied to them to get more efficient with those sums for addition. And then in my small group, I'd pull over some kids and work on decomposing activities and be there right before that, providing that scaffolded support for them on that journey for this particular student for that strategy. So you might be wondering, okay, math running records then, when do I give these? Who do I give them to? In the school that I was a math coach in, we gave it to every single student. Every student deserves for us to listen to them about their thinking so that we can better meet the needs of the kids in our classrooms. Now, I know it may not be feasible for everyone to get that done, but it is something that I do recommend that every student be interviewed, because so many times people are surprised. The students they thought would not do very well do really well. And other students they thought would be, the other high flyers or whatever, like you find out they've got no depth of thinking mathematically. It's just memorized and they're quick and fast. So we think they're presenting themselves as being great at math when actually there's no conceptual understanding to back it up. So it's really fascinating and really important. We talk to all of our kids. So by the end of kindergarten, we do want to give adding and subtracting. We don't want to forget about subtraction. So I do adding and subtracting in grades 1 and 2, beginning, middle, and end of year, adding and subtracting. And then in grade 3, we want to begin the year with adding and subtracting. But then by the middle of the year, once they've had the understanding and the exposure to what multiplication means as an operation, then we can begin giving them the multiplication one. And grades 4 and 5, I honestly have found in my consulting work the last many years that subtraction is the Achilles heel of all our kids. We've not given as much instructional time to subtraction as we have with addition and multiplication. So the kids are not having any flexible strategies with subtraction. So I highly recommend we do subtraction with our upper elementary kiddos, and multiplication as well, which will tie into the content of the grade level as well. And adding and subtracting is in the world of upper elementary, it's just with fractions and decimals, but the same strategies can be used. So it's really a powerful journey. We also want to make sure we think about the journey of the kids, that it's not do addition until you've mastered them all and then you go on to subtraction. We want them to be able to add and subtract within 5 first as a foundation. Then we can build on that to help them add and subtract within 10, and then to add and subtract within 20 as a journey. So if I'm a first grade teacher and I find out my students in the middle of the year are up to their doubles facts with addition, I would not have them work on those. Before I check them for subtraction. If the subtraction facts within 10 are not mastered yet, then they work on that. So it's possible in your classroom, if you're doing a math workshop model, that the students go to a Fluency workstation. Some students might be working on addition and some might be working on subtraction. It's what they need, meeting them where they are and what they need. So as kind of a summary of addition, there is a progression, suggested progression for differentiation, as there are for all 4 operations, a suggested progression of these strategies. For addition, the heart of it is to be able to break apart numbers, to put them together in more and in easier ways for our brain, but it will also make a foundation for the future. So for example, if I think about 98 plus 54, the heart of addition would be the bridge 10 strategy, that I can make the nearest 10. So if I were to ask you 8 plus 4, one way someone might think about is to break apart that 4 and give 2 of it to the 8 to rename it as 10 plus 2. So I know that it's a 12. Well, we can forward that to like double-digit addition. 98 is just 2 away from the next 10, which is actually 100. So if I take 2 from that 54, I can rename this as 100 plus 52. And the answer is 152, right? When students begin too early in their math journey, it's actually a 4th grade standard in most states. In the Common Core, it's a 4th grade standard to add and subtract with the algorithm. They get locked into that calculation of lining things up and regrouping, and they don't have any number sense, right? I hear that all the time. Well, we need to take that time to give them the chance to think about that as we do triple digit addition. Not that this will work for every single set of numbers, but if you give me those numbers before I line them up and begin cranking out my algorithm, I'm going to say, wait a minute, that 298 is just 2 away from 300. And I can write that down. It doesn't have to be mental math in your head. It can be writing that down. I can change this to be 300 plus 154. so much easier for me to do, right? But that also can work with fractions. With 4/5 and 3/5, I know my 5th grade classroom, all I knew at the time was to help my students understand why we add the numerators and not the denominators. But then it felt weird because we had a large number on top, which felt improper. We called it improper as if there's something wrong with it. And then we had to convert it to a mixed number. For some reason, I forced them to do that too. Well, what we can do instead is think about decomposing the 3/5 as we did whole numbers, breaking apart a 3 into all the pairs of addends. We can break apart 3 1/5 into 1/5 and 2/5, because that 1/5 can join the 4/5 to make a whole. So I can rename that as a whole plus 2/5. We can include so many more kids on the journey. Similarly with decimals, I knew when I taught this lesson, I taught it procedurally, line them up, decimal places, and then you go do the regrouping as usual. I knew there'd be a handful of my kids that would not follow it correctly, and they would give me the answer of 1300ths. And I would say to myself, they have no number sense. How can 1300ths be the answer when you're beginning with an 8/10? But then I did nothing to help them build their number sense with decimals and fractions. So, but when you know more, you do better, as Dr. Maya Angelou says, and that's just so true. When we think also about the algorithm, the double-digit algorithm for addition, let's think about the thinking of the kids. We tell them you must start with the ones place. You don't have to. You can add tens together first if you want to. But because the procedure, we say you must start in the ones place, and then the regrouping happens, right? And very often the students don't know 8 plus 7 is a 15, and so they count on the 7 from the 8. So they're in a counting phase of reasoning. So that counting phase of reasoning is happening within a double-digit addition problem. So we want to do better than that, right? We want to have other flexible strategies, and that this sets a foundation for the math running record. So as a summary of math running records, there are those 3 parts. All 3 are important. Just don't do one. I've met some teachers that, they first learned about them and they were crunched for time and they only did part 1. But part 1 is just that relative speed and accuracy. We want to do part 2 with a deep dive and find out that profile for the entire student, that well-roundedness of them as a mathematician. The intention is for an instructional response. It is not intended to give a grade. We've got to find out information authentically about our students, what they know, to help them build from what they know to what they don't yet know. And it will impact your entire instruction of the classroom, of exploring mathematics, as well as being able to help our students move forward wherever they are on their journey. And honestly, it will also affect your data discussion meetings and professional learning communities. The discussion of the skills of a student. We want to make sure we are focused on what can the student do, not what they can't do. We want a strength-based mindset of what are the positive things a student is bringing to the table, and we find that out, and then we can discuss that as colleagues by having the rich math discussion of the trajectories of their learning. I've sat in a lot of data meetings with primary grade level teachers, K1 and 2, and they're very specific about the literacy skills of their kids. But when asked about math, they'll say, oh, he's a fine. Right? There's no specificity. And whereas math running records can change the conversation to be much more specific. I love this quote here. And I would say it's not just kids, it's also adults, right? It's not the math people hate, it's those feelings of being confused and intimidated and embarrassed. We want to open that door for all of our students on that journey. Now, I do want to share with you just a little bit about subtraction because it is the Achilles heel. Unfortunately, my dog, Marty McFly, is choosing to bark at nothing. And my husband's not home right now, so I'm sorry about that. But here's the progression of the strategies for subtraction. So again, they are in order from the easiest ones to the hardest, the within 5. We hope to be in place by the end of kindergarten. Again, minus 0 and 1, and then a number from itself as well to know you're left with nothing. And then the within 5. By the end of grade 1 to have within 10. And then the teen numbers subtracting a single digit subtrahend, those are hopefully by the end of grade 2 that those will be in place. I don't find this to be as linear a journey as the addition is for the kids. I find that I catch them even upper elementary at this within 10, because one of the questions I ask them is 8 minus 6 in part 2, and they count back the 6 rather than even knowing they could count up from the 6. So that gets to be, I get a lot of kids there, even the upper elementary kiddos. These tend to go pretty quickly. They're numbers that have a difference of 1 or 2. Here is teen numbers, removing the 10 or the 1s grouping. These are half facts. That's where I get them next. They don't recognize it as a half fact. So the same student that knows 7 plus 7 makes a 14, when you ask them 14 minus 7, they haven't linked together the inverse operation of adding and subtracting yet. And then this is the heart. This is where all of our kids get stuck. It's those teen numbers minus a single digit subtrahend. And so that really is the journey. It looks like it's almost done, but in subtraction, that is really the subtraction journey. But again, the leveling, the research levels are the same. Kids are going to be counting all, but in the context of subtraction, they'll be counting back. So they might be counting back or they might be counting up. And they'll be using their fingers sometimes. They also might be doing that in their head, counting back in their head, counting up in their head. And here we have the derived strategies. I'll be talking about that in just a second. And then we have the mastery again as well. So we're trying to figure out here on the trajectory of what sets of numbers are there. And then within those sets of numbers, what is the progression of where are they on the strategy levels? So the heart of subtracting within 10 to move them beyond the counting back is to decompose numbers. Now, one of my favorite manipulatives is Cuisenaire rods. You'll find a document on the Padlet link that I gave you that has a printout, a 5-pager that I wrote about how we can get started with them. But what you're seeing is the 5 rod being decomposed into all the pairs of addends. This is the 4 rod and the 1, the 3 and the 2. And here's the community properties kicking in. So the 3 and the 2 is becoming the 2 and the 3 and the 1 and the 4. Marty. And here you have the 6 rod and decomposed into all its pairs of addends, 7, 8, 9, and 10. So I do find that students are decomposing more often now in classrooms, the 5 and the 10. We just forget to do 6, 7, 8, and 9 as well. That will help the fluency for adding and subtracting within 10. When we get to the teen sums, again, using 10 as a bridge. So very often students are used to thinking of subtraction as things are getting removed or eaten or given away. This is a take from problem type where there's that action removing items. And so when I put the 8 Cuisenaire rod beneath that distance of a 15, this might encourage them to move beyond counting back one by one and instead remove it in 2 chunks. Let's remove the 5 first, because we know that 15 is made up of a 10 and a 5. So if I remove the 5 first, I land on 10. Well, if I want to remove 8, I have 3 more to go. If I decompose an 8 to know that an 8 is made up of a 5 and a 3. And then I know 10 minus 3 is 7, because I know 7 and 3 make the 10 for, again, the decomposing. So I also can record that for you abstractly. So I'm showing you the concrete, pictorial, and abstract of linking these representations together for our kiddos in all math concepts. So I put that here as an abstract way of showing you that thought process. But the key to subtraction is the flexibility of thought, because subtraction is not just removal. It also is the distance between the 2 numbers, such as a comparison story problem, where if you have $15 and I have 8, how much more money do I need to have the same as you? Well, that's encouraging additive thinking, right? And I can count up. I can begin at the 8 and count up to the 15, but I also can do that more efficiently by doing it using 10 as a bridge. I can say, well, from 8 to 10, it takes 2 more. And then from 10 to the 15 is 5 more. And that distance is 7 in all. So I can think about that 8 plus 2 plus 5, and that's my distance. Those are the flexibility strategies that we need, because depending on the numbers that you were to give me, whether it's multi-digit numbers, mixed numbers of fractions, or decimals, I'm going to choose my strategy based on the numbers that you give me. I just don't have one strategy. So I want to show you this quick little 1-minute video, one of my favorite moments ever of, I had asked her in the running record, 14 minus 8. And she started at the 8 and she counted up one by one to get to the 14. So after the running record, I had this conversation with her.
When I asked you 14 minus 8, remember how you put up your fingers and you thought about and you counted up to get to the 14? Mm-hmm. I'd like to try it with you again, but this time let's use the number 10 to help us. So how far is it to get from 8 up to 10?
2.
And how about from 10 to the 14?
4.
So what's 2 plus 4?
2 plus 4 is 6.
So guess what 14 minus 8 is?
I love that moment. Right? It's just eye-opening that you can even do that, right? And it just can open the world up to students who typically have not been included in that math journey. And so also thinking about that future impact. So here are some numbers that I wouldn't want to remove the 90 and remove the 8, right? You can think about adding up. 98, it's 2 more to get to 100 and 2 more to get to 102. That's just one of many possible strategies, but that's a great one to do like a number string with you as pre-service teachers to see the impact this can be, right? This subtracting from numbers that have all these zeros, it's a nightmare for the kids. But I can use addition to help me solve subtraction. I can think about adding up, and I could even possibly do that in my head. Same thing with decimals, right? Very often procedurally, kids are forgetting to put the decimal point in the 0, then they have to regroup. But I can think about 2 7/10 is 3 more tenths to get to 3 and another whole. So it's a whole and 3/10, right? And similarly with mixed numbers. When you give me mixed numbers, I never do the regrouping method. It's just so inefficient. There's so many other ways we can think about subtracting that makes much more sense and conceptual understanding. So as a summary of subtraction, there is, again, a suggested progression of difficulty of the facts. The flexibility is the key, knowing that I can remove subtrahend or I can begin with subtrahend and I can add up to get to the minuend. And it will, even with the basic facts, set a foundation for the future. So when we're thinking about that algorithm that I see way too often in grades 1 and 2 classrooms, thinking of the kids, they have to know how to do the appropriate regrouping, but then typically they are counting back the 7 from the 13, and then they'll count back the 3 from the 5, and they're not able to see the place value here, and there might be many more efficient ways of subtracting that. So in terms of like next steps, so that's the math running record. Introduced you to the idea of adding and subtracting, some of that flexible strategies behind the thinking of those operations. But in terms of some just ideas of some next steps for you for embarking on fluency with kids and giving dedicated classroom time to that in your classrooms, this is a book that I've written with Dr. Nikki Newton and Dr. Allison Mello that gives you some ideas of the next steps for adding and subtracting. We are currently writing the multiplication and division. Dr. Nikki always says fluency doesn't just happen, it is a well-planned journey, right? It's not just having kids play games with flashcards. And so what we've done is I've created an Excel spreadsheet for the math running records where when you've given them to kids, you can then put it in the Excel spreadsheet. Then you can sort the sheet by the strategy. And there are your small groups. There are your groupings that are going to be targeted work to help them work in that zone of proximal development to help them move forward. And so what you have on here is what strategy they're working in and then what level are they in the strategy. So you can see these kiddos, this is a first grade class, I'm in the middle of the year. These kiddos were working on their add, make 10 facts, and they were finger counting. These kiddos were add, make 10 facts, and they were counting in their head. So I can even further differentiate within the groupings that I'm working with of where they are on that trajectory of learning. And so we always want students to be able to explore these number relationships, these strategies, using concrete and pictorial and abstract ways and combining those representations. It's not a linear journey of today you do concrete and tomorrow you do pictures. It's always connecting those representations to make these bridges between these different representations. So using math tools like these 10 frames of cubes or Cuisenaire rods or these Rec and Recs as well, where the structure of them help the students understand the benchmark of 5 and 10 and those number relationships. Then having pictures, and you can certainly still have flashcards, but you can have visual scaffolded support for the kiddos. And then abstractly, they can play games and activities as well with the numbers, but not forgetting to do the pictures and the concrete before we get to the abstract numbers. And so I do want to let you know the Padlet again is tinyurl.com/mathrr. And on that Padlet, I have created videos for each of the strategies for addition and subtraction. So if you happen to give a running record for a student and you find out, oh, they're in this particular strategy of doubles plus 1, you can go and watch my video and see how I explain the thinking behind that strategy and some math tools you can use to explore with the kids, those number relationships. So let you know that is on the Padlet. And a few games ideas of how we can differentiate once we know what the students are beginning to working on is we can be sorting dominoes, any flashcards as well. So rather than having flashcards and just giving an answer, let's sort them by the strategy we might use to solve it. So if we see a 4 and a 4, that would that's a double strategy. Here's a 5 and a 6. That's a near doubles, right? And it can be a strategy that you might use. Maybe I would rather here use 5 from the 6 to make a 10 and then one more. So I could put this domino under the bridge 10 if I wanted to. So it's not just one right strategy, but it's what would you use for those facts? So you sort them, and then always don't forget to have a column for other, because you don't want to pre-sort these. I was as the math coach, I'd be working in classrooms and I would be a workstation. So kids would come to me, but I knew what strategy they were working on based on the running record. So this grouping here was working on their doubles. So I gave the doubles title, but also some that came before it in the progression. Now, when the next group of kids came over to me, let's say they were working on their make 10, I would put all the dominoes back in a pile, but I would take off this column of doubles, and instead the kids are finding ones that make 10 or count within 10, counting on 2 or 3. I wouldn't have that as an option yet because it's not there yet. So sorting things by the strategy you use to solve it. This is a game called Kaboom. You use for any operation and any set of the strategies. I did create plastic baggies of the popsicle sticks that are by strategy. So I knew what facts were in the cup for the kids I was working with. What you also do is you add in some Kaboom sticks. So as the kids take a stick one by one and they tell you the answer and explain their thinking, if they happen to pull a Kaboom stick out, then all the sticks they've collected go back in the cup, just that one student. And so, you know, at the end of the game, it could be the person with the most sticks or the person with the least. I kind of do sometimes I roll a die, 3 sides say more, 3 sides say least, because the kids disengage if they feel like they're going to lose. It's like playing war. If you keep taking my cards in war, I'm disengaging. This is not fun anymore. But if we can play our entire game of war and at the end find out that the winner is a person maybe that had the no cards left, then I can still stay engaged in that game. 2 more ideas for you here. The true false, being able to use relational understanding of the numbers to know whether the numbers are true or false, that you wouldn't necessarily have to solve it for the numerical answers. You can use reasoning, and then you can double check it on a number balance. So always, and again, any operations, and then you can be able to double check it on the number balance. And things like power towers, where you create a plastic baggie full of Dixie cups. On the outside is the expression, on the inside is the answer. So as I answer this and tell you my thinking, you as my partner can tell me whether I'm right or wrong. And if I'm correct, I get to put it on top of a power tower. I can build my towers with my cups. But I do know that the kids using this baggie are working on their multiplication 4 facts and the ones that came before it in the progression. They're not seeing 8 times 9 yet. They're not ready for that yet in this kind of building the automaticity with the facts. And I also want to let you know, too, about a site, and this is linked for you, and descriptions of those games are also on the Padlet for you as well. But this is a wonderful site you want to explore if you haven't seen it yet. Kentucky Center for Mathematics created many of the games in this wonderful book by Jennifer Bay Williams and Gina Kling called Math Fluency. And they have lots of games you can play either in Jamboard virtually, or you can do it in person. You can print out the directions on the game boards as well. And one last plug, as you guys are embarking on your career as teachers, it's so important to include the parents on the journey. Unfortunately, during the pandemic, I saw so many of these memes and people finding it hysterically funny because they were living it, because they don't yet know why we're teaching math the way that we are. So I do ask in the districts that I work with to have parent nights so we can get the parents in the door. They can play games and activities with their kids and learn to understand why we're doing what we're doing. So I will talk with the parents for a half an hour. And just create that climate and that culture in a school that we all can learn math, and it can be really exciting. And so there are also wonderful resources online specifically for parents. And so I decided to create a Padlet for parents where I can gather these resources from these wonderful books and videos and things and websites that are designed for parents. And so that's just a tinyurl.com/record parents. So you'll find that as well. I've done some also some Fluency letters home to parents to have the parents help the kids with the math facts. I explain the progression of the strategies and the reasoning behind them. So those are on the Padlet for you as well. In fact, also in other languages. One of the people I have in the Facebook group, she had someone translate them into Portuguese and Luganda and Haitian Creole and Spanish. So those are available for you as well. So just want to remind you again that I love to learn and grow. I do learn more every single day. I'm happy to share and talk math with anyone. So AnnEliseRecord.com is my website. You can I do a newsletter once or twice a month where I hook you up and let you know about upcoming trainings and free PD that is out there for you. I do have some on-demand courses as well, and those Padlets from problem solving, as well as for the core standards as well that you can get. Those are free on there as well. So Dr. Maya Angelou says, do the best you can until you know better. And then when you know better, do better. And I really feel like I've lived that. I want to go back and apologize to my fifth graders that I had all those years because I know so much more now. And I know more about how I can meet the needs for them and build a positive journey for them. I just didn't realize what I was doing at the time.
This was amazing. I think just about every question I had written down for you, Ann Elise, you actually answered, including
funny.
how to deal with parents that don't understand Common Core. I love your idea to do the math nights with the family. It's such a great one.
Mm-hmm.
But yes, I think, at the heart of good instruction is knowing where your kids are at. And those running records are really going to get you there so that you can, as Ann Elise shared, really focus in on your students' zone of proximal development and then differentiate your instruction. So whether you're doing a math workshop and kids are rotating, I love the games that you shared. Kaboom. I was thinking, that reminds me of Old Maid. My daughter loves that game. At the card with the old maid, and then you're like, oh no. But my only other question, and I'm not sure if you said this, because obviously you talked about this being a formative assessment, right? It's something that's not graded. We're going to look at it to help us inform our teaching and learning. How often should teachers be doing these running records in terms of the frequency?
Yeah, about 3 times a year, beginning, middle, and end.
Okay.
It's suggested benchmark ones. If you're working as an interventionist with students, you can do it more frequently. The only difference is when you're doing it again is you would start part 2 at the last strategy that left off in. You don't have to go back to the +0 facts. So for that little girl today that I showed you, if I interviewed her again, I would do part 1 over again and see if she fixed that 2 + 3. And but then in part 2, I would go right to the adding within 5. I'd ask her, the 2 + 3, and can she do that? And then I would do the within 10 facts. And then I'd go from there and see where she currently is, right? And there's no time limit on that. It could be a week. It could be a month. It depends on the child and how much time they've been able to put into it and explore them. So
awesome. I love it. Thank you so much for coming on tonight and talking to future teachers and those of you that are in the classroom. Definitely check out the just amazing ton of resources that you've curated, and it's all free, which is awesome to see. So definitely check it out and join the Facebook group. I'm on the Facebook group, so you should be too. And join us next week. We're going to have Berkeley Everett in the house. He is going to come and talk to us about math flips.
Oh, fantastic. It's one of my favorite go-to activities for the exploring of the strategies, the math flips. Absolutely. It's fabulous.
And the book, if you could just share with us, because I want to get the book. I have the strategies. I want to see what else is in there in terms of, okay, now that I've done this assessment, what's next?
Yeah, all the next steps, right? Yeah, so there are ideas for videos and picture books and workstation activities that are concrete, pictorial, and abstract. Word problems you can use. It's a wealth of information for each strategy for adding and subtracting, as well as chapters on including parents in the journey and the research behind the fluency journey for kids. So, yeah, it's all encompassing.
Definitely check it out. And join us again. Thank you so much, Ann Elise. And I know it's East Coast time, so you're probably so tired.
It's 10:06 right now.
Well, have a great evening, and thanks so much for joining me.
Thank you so much. It was a pleasure to be here. And good luck, everyone, on your careers. Welcome to the wonderful profession of teaching.
Start your PD now. Follow Ann Elise. Get all the PD in, soak it in, and who knows, 10 years from now, you can become a math consultant too.
That's right. You never know. That's right.
Absolutely. Well, thanks for sharing your journey with us, Ann Elise. I hope to have you on the show again soon.
My pleasure. Thanks so much.